Yeah, you can unmute. Maria K, you can unmute. Oh, okay. Enoch.
Media. Let us humble ourselves for a word of prayer. Most gracious Father, we thank you for this moment. We thank you for you have brought us as your children this afternoon to share this knowledge in this mathematics lesson. As we're going to commence, may Holy Spirit come and guide us. May He come and guide the lecturer that is going to lead us. May He also give us the knowledge to understand all that we're going to study today, that He might bring glory to your name through the mighty name of Jesus Christ, our Lord and Savior. Amen.
Okay. Thank you for the word of prayer. Thank you for the word of prayer, and you are most welcome, everyone. Uh, I have a question there, and I'm going to ask you to let me know, or you can share with us, how you think we can be able to estimate the area that is covered. In case you have an idea, you can raise up the hand and you share with us. With an idea, how do you think we can estimate the area? Let me look through the charts and see, and I check whether any one of you has an idea how we can estimate the area. Okay, I think we do not have an area. So as we dive into this lesson, Uh, these are some of the questions we are going to be able to answer. So the question, or what we are going to look at today, will help us to know how we can estimate the area for anything. So that was the first question to let us think. What about if you want to find the amount of glass to use for such a building? How can you estimate the glass you will need? Now, this is what we are going to look at today. So in order for you to be able to estimate the amount of glass you will need for this kind of building, for maybe to support you to finish the work, it is today's topic that is going to lead us there. Still, if you want to find out the area that has been covered by the lake, I know some of you have kept on wondering. They will tell you that maybe Lake Victoria has this kind of area in your geography or at O level. You have been wondering when they tell you that this country has this kind of area. How do they come to estimate that that is the area that has been covered by that particular water body, by that particular see by that particular object. So whenever we have those objects whose area is irregular, then the approach we are going to use is what we are going to start on today. So we are going to use today's lesson to build a foundation that will enable us to learn how we can estimate the area of an island, how we can estimate the amount of glass needed for the windows of a building, and we are going to represent everything using what we call integrals. So today's lesson is going to enable you, is going to give you a foundation on how we can estimate, on how those things you have kept on wondering can be dealt with. I know you know the topic because I asked you which kind of topic do you want to look at. And according to the poll, I noticed that many of you wanted us to start on integration. So I'm going to ask you that let's now write our topic. Now, all those first questions I was asking, those probing questions are going to be answered by the topic of integration. So you write your topic that we are starting integration. Yes. So whenever you have those irregular objects, those irregular shapes, and you want to estimate their area, the space they have covered, the only knowledge we shall be using is going to be the knowledge of integration. I also know that you are going to keep wondering, but where am I going to use this particular topic in real life? I've showed you a sample. Whenever we go in for estimations, those who are going to go into construction, someone has asked you for a quotation. You want to estimate the kind of materials, the kind of what, and the rest of that. You can use this approach of integration for you to be able to do that. I hope now everyone has finished to write the topic. Okay, so we are going to start our topic. Now, our competence is what should you be able to know by the end of the topic. That is the competence. So our competence, by the end of this particular topic, these are the things we expect you to know. So I want you to first write that competence down and then Okay. Hope now everyone has finished to write the competency. Okay, people have finished. Okay, people have finished. Okay. Okay. Now we are going to continue. Now, in our lesson today, the major area of concentration is going to be one, we are going to relate integration to differentiation. I have taken an assumption that in the schools where you are, you have been able to cover differentiation. So we are going to look at how is integration related to differentiation. Then we are going to go on and look at what we call the finite integrals and what we call the infinite integrals. So those are the ones we are going to look at today in our lesson. And it's going to be our major area of concentration. Now, let me ask you to write out the key concepts. By the time we finish this lesson, all these concepts here must be in your head. You must know how integration is related to differentiation. You must know what you call a lower limit, what you call an upper limit, what you call the constant of integration, what you call an indefinite integration, what you call a definite integral, and what you call an antiderivative. So you summarize those four concepts that are going to be key in our lesson. In case you are here and you are for sub-math, it is very okay. Do not run out, it is okay. Hmm. Oh, now those who have not yet started, who have not yet covered anything with differentiation, no problem. I'll try to do something about it. Hmm. Okay. Okay. When you finish write the key concepts, you let me know, and then we start. Okay. People have finished. Okay. Okay, now we start. The first one is going to be a skill check for the people who have done differentiation. So may I ask all the people who have done differentiation to type quickly in the chat what could be their answers for this particular part. Now, for people who have not yet done differentiation, when we talk about differentiation, differentiation means breaking something into different parts. An example I can give, take an example, this is a piece of chalk or this is a stick. When you break it into small particles, like this, like this, like this, that's what we call differentiation. So differentiation means breaking something into different parts. That's what we call differentiation. Now, when we are differentiating anything, we write differentiation as d dx, and this one can be dy. This is what we call the derivative. Take an example. By definition, dy dx is given by x. If you are differentiating, this is going to be n xn minus 1. That is by definition. What does it mean? If you have your function y is equal to x power 2, the first thing you do, those who have not yet done differentiation, you drop the power. In other words, the function we have been dealing with is y power xn. I drop the power, it becomes 2. Then this power, I reduce it by 1. So we have here x 2 minus 1. So you get your answers 2 power x power 1, which is the same as 2x. That is by how we differentiate. In case you have y is equal to x power 3 and I'm differentiating, I first drop the power. So when I drop the power, I'll get 3x. Then this power, I reduce it by 1. So I say 3 minus 1 and I'll end up with 3x squared. So those who have not yet done differentiation, that is what we mean by differentiation. Okay. Yes, Sam.
Um, I wanted to give my responses, what I've tried getting.
Okay. You tell
So
us, for the first one.
for the first one, I
Hmm.
have 3x squared minus
3x squared
minus
minus
14x to the power
minus
of
plus
minus
minus
14x 14x
14x
to the power negative 3.
negative 3. Okay,
Then
thank you. Then the second one,
the second one, I have 10x minus 1.
minus 1. Okay, thank you, Sam. Some don't go off, some don't go off. Remain there. Enoch,
For number one, I have 3x squared plus 7. Then for number two, I have 10x minus 1.
okay, okay. I want one more. This is the second answer. Another person to tell us what you have for that part. Uh-huh. Sarah,
Yes. Number one, my answer is 3x squared plus 7 over 2.
3x squared plus 7 out of 2. Okay. Thank you, Sarah. Okay, now we
Yes.
are going to start our discussion from here. Now, for this part, I agree with you. All of you agree that the answer is the same. But when it came to this part here, there was a problem here. Now,
Yes.
Sam, you messed up with this. Now, there is a difference, Sam, between uh, between 7x out of 2 and there is a difference and 7 out of x power 2. Now, in your attempt, when you are attempting, this is what you did. Are you getting it?
Yes.
This is what translates into 7x power negative 2. So that is where you messed up. So always differentiate when the x is up or when it is down. So that is where the mistake was. So here, there is a problem with this, with that part there. Hope
Okay.
that is okay.
Yes.
This. Then for the second person, he forgot to put out of 2. Because here the coefficient was 7 out of 2x. So he forgot to put out of 2. So that was the mistake for that part. Okay. Mohasimin. Okay, I think we are going to continue. So that was the mistake for that number. Now, what is our task today? Our task is going to be the answer we have got here. Our answer was 10x minus 1. And this is the answer we got. So we are going to look at how do we move from this particular answer we have obtained back to the original thing. That is going to be our biggest task for our lesson today. But where do we apply integration? Some of you, I know you have been wondering, why is it not so common to find planes crashing in space? Whenever they are designing, whenever they are planning flights, the knowledge behind everything is this knowledge of integration. Whenever you are planning things concerning the flight, there is that knowledge of integration. Though you may not be able to see it, then I know you enjoy games, those computer games you see. But behind that knowledge, when we are doing what we call game modeling, we use the knowledge of integration. So for you to know the position where maybe that vehicle is going to be, to determine the speed at which it is going to move, to calculate the position and everything, to determine when the character, when the bullet, when the ball is going to be moving and at what speed it's going to be moving at. When someone places the button, the knowledge behind is the knowledge of integration. So when you go into gaming, you'll find that this knowledge of integration is used. So these are some of the few applications when you start doing things where you'll find this knowledge of integration being used. But also I've told you earlier on that also when we are estimating the areas of a given place, you are estimating the volume that a given figure can carry. Take an example. Sometimes, let me say you may have a polythene bag and you want to know how much water it can carry. So such things of estimation of the volume, you want to estimate the area, the knowledge of integration will be paramount. Okay, kindly let me know through the chat whether we are good to continue. Okay. Okay. Okay, I think we are good to continue. Okay. Now we continue and start. I'm going to, I want you to observe my screen. From your question, I want you to put for me in the chat which answers, when you differentiate the first one, does everyone agree, for even those who have not yet done differentiation, that when I have y is equal to x power 5 plus 4, remember, for those who have not yet done integration, whenever you find a constant, here there is an x to power 0 that is hidden. So differentiation of our dy dx will give us, when the 5 drops, you'll get 5 x power 4 plus 4 times 0 becomes 0. So that's why for that one, we ignore it. Because this is 0, once it multiplies the coefficient, you'll get 0. So you'll agree we shall remain with 5x power 4. Now, what do I want you to know? That when you differentiate the first one here, this is the answer you get. When you differentiate the second one, this is the answer you get, the one in yellow. When you differentiate the third one, you get the same answer. When you differentiate what we have on the left, you get the same answer. Everything, no matter what is contained within here. Do you agree with me in the chat? Let me know. Very good. Juliet has concluded that all give the same answers. All the answers are the same. Yes, everyone agrees with me. Now, what is going to be our biggest task? Our biggest task here is us asking ourselves, how do we move from the answer here? Are you seeing our answer here? How do we move from 5x power 4 and we come back to the original thing we had? How do we move from 5x power 4 and we come back to the 0.5? That is the big question that we are answering today. So the moment you find out how we can move from where we were and we come back from this answer we had, and then we get back, that is what we are going to work on. I don't know whether that is clear. So what am I telling you, or what are we doing? What we are trying to find out is that if you have this answer here, this is your answer. How can I come back? And now that process is what we call integration. I have told you that differentiation means you break something into small particles. Whenever you are eating food, you are differentiating. Food is being broken by the teeth into small particles. That's what we call differentiation. Now, combining these parts here to form one combined thing is what we call integration. I repeat, differentiation means you break something into small particles or into smaller parts. Then integration means combining everything into form one bigger part. That is the simple meaning of the word integration. So you combine all the particles you had broken down to form one bigger part. So in the process of eating, our body always differentiates and then also it integrates. So it does two things at the same time. So now I want you to notice one thing here is when it comes to integration, for us to move from our answer here, I want you to take note of what we do. When you look at 5x power 4, let me first use this one alone. I'm picking this one in red. Our original function was x power 5 plus 0.5. Now I'm going to ask in the chat, you tell me, this is what we have to take back this side. Tell me, how can we remove this 5 here? How can you tell me through the chat? How can we remove that 5 if you want to obtain something similar to what you have this side? Put in the chat. How can we remove that 5? Enoch, do you have the answer?
I can try.
Tell us,
So
Enoch.
the way to remove the 5,
Hmm.
we get, first of all, we're having 5x power 4. We add plus 1 to the power that is there. We get 4 plus 1. Then we divide by the new power that it is going to 5, which is the 5. We divide by the new power it is going to have, which is the 5, to remove that 5 to go back to the x power 5.
Okay. Thank you. That is very okay. Okay. That is okay, blessing. So we shall divide here by 5. Now, after dividing by 5, that is what you do. You divide by 5, and then this one, your power, you add a 1. So you end up with x power 5, then plus something. But I want you to notice because I want to explain one thing. The thing I want to explain is that you are noticing that the answer you are going to get when you go back, all your answers are going to have this. But you notice that this plus 4 plus 7 plus 0.5, negative 3, negative 7, negative 45 are totally different, even when the function is the same, even when you integrate. So what does it mean? That thing that makes that thing different is what we call the constant of integration. So whenever you integrate, because we are not sure whether that function had a 4, whether it had a 7, whether it was 0.5, whether it was 54.5, whether it was negative 7, whether it was negative 3, you are not sure at all. So that's why we keep on adding. And I'm going to emphasize it that whenever you are doing integration for an infinite function, then we shall always add a constant of integration. So when I'm integrating, let me say I have here. When I'm integrating, we have 5x power 4. So to get back to this original function, you always get the power here, you add 1. So you add on your power, you add 1. After adding on 1, what you have, you divide it. The new power, you divide it. So it will become 5 out of 5 x power 5, then plus a constant of integration. So this 5 and the 5 cancels, so you get x power 5 plus c. Now this c is what stands for the constant of integration. So c represents negative 3, negative 7, negative 54.5, 4, 7, and like that. So that is why we always add that c. So whenever you are going to be integrating, we shall keep on adding c to mean that you are not sure which constant was there. Secondly, I want you to note that I told you that differentiation means breaking and integration means adding. So that's why we call them the reverse. That's why we call them the what? The reverse. that differentiation and integration are reverse of each other. In one, you are breaking. Another one, you keep on adding. In differentiation, we are subtracting the power. In integration, we are adding the power. Kindly let me know through the chat whether you have picked something. Bit when it is having a negative sign, you do the same. I want you to let me know through the chat whether we are there. Okay, people are there. Okay. How to get the constant? How to get the constant? We are going to reach there. How to get the constant. Now, this process of the reverse process is what we call the anti-differentiation. And when we call it the anti-differentiation, there are two scientists that came together, and that was Newton and another one was called Leibniz. That one, they agreed that now let them call everything integration. So whenever you hear the word integration, that is what you call the second calculus. You did the first calculus, which was mainly differentiation, and now another second calculus is what we call the integration. What does C stand for? C stands for the constant of integration. Constant, these numbers here, the 4, the 7, the 0.5, the -3, -7, negative what. Those numbers that you cannot easily tell whether that was the number, that was the original function, or that was not the original function. Okay, I think, are we good to continue now? Mohasimin, class, are we good to continue? You can let me know. Yes,
Hello. Good afternoon.
good afternoon.
No, yeah, I'm sorry to interrupt, but in my former school, we haven't looked at integration here. So I was asking if you can take me through this first formula of integrating from
We are getting there.
y. No, I mean
Eh,
like this one, y equals to x power 5 plus 4. Like, how do you get this 5x power 4?
okay, we
Yeah,
are going to
that,
get there. I was giving you like a brief, eh?
all right.
Okay. Now,
All right.
I want everyone to summarize something from this slide. Look at the slide. I've given you the key points I'm interested in. So I want you to look at the slide and then pick some key points you think are going to be. This is our first key point. And our first key point is showing you what you get. So this is our derivative here. This is our the thing we were in differentiating, and we got the answer. So this is what we get as our result. So this is the integration. So I want you to summarize something from this slide. Summarize something, what you want, and then here in words is what now I want you always to remember. Whenever it comes to integration, the power, you increase it by 1. And then after, divide what you have obtained by the new power. This is what I want. Increase the power by 1 to obtain the new power. Then divide by the new power. And then do not always forget to add a constant. So I want everyone to summarize something from that slide. When you finish, you let me know through the chat. Yes, Said Mercy, we do add. We add. We keep adding. It doesn't matter. I want to explain the key point. Like we have said, that in differentiation, I want you to remember, in differentiation, always you say y is equal to maybe x power 4. When you are differentiating, you get dy dx is equal to 4x cubed. Now, in integration, you finding this y is what we call the integration. So, in order for you to find this y for something you have differentiated is what we call the process of integration. So that's what we are looking at. So, the first one, it is the first format. The second one is the second format. Remember, when you are differentiating, I know you have dealt with functions whereby they have given you a function 4x squared plus maybe 3x. Still in differentiation, you have been doing f prime of x is equal to 8x plus 3. That is from your differentiation. So here, still it is the same thing. What was your f prime in differentiation? When it comes here, it goes back to f of x. So you take it back. Then, thirdly, I want you also to take note. I know you have been seeing a snake thing in your books or in the books you have been reading. That snake sign is what we call the integration symbol. Whenever you find that snake thing is the integration symbol. Okay. When you finish, you let me know through the chat and then we continue. That elongated S, and you'll meet it in physics. Eh, okay. Uh-huh. Okay. Yes, Maria.
Excuse me, teacher.
Hmm.
Like, why is it that they are saying that okay, like n must not be equal to -1?
Oh, why n shouldn't be -1, eh? In other words, what will happen, Maria? If this n here is equal to -1, we shall have n plus 1, which is -1 plus 1. -1 plus 1 is 0. So it means that here down, you'll have something like 1 out of 0, xn plus 1. So when 1 out of 0, this is undefined. So it is showing you that down, you can never have a 0. That is the meaning. That you can never have anything 0 down. Okay. Hope, Maria, that is okay.
Yes, teacher, thank you.
Okay. Anak, okay. Okay. Yes, Lugalama. Okay,
For
Nat.
me,
Mm-hmm. Oh, okay. I'll fail to get you. But let's continue. Hope people have finished to summarize. Then we go to the second slide. I'm also going to request you to summarize. Summarize something from this slide as well. Yeah.
Good afternoon, sir.
Yes, good afternoon.
Sir, for me, I was requesting for pardon on because I was not understanding the first key point that was saying if the y out of the x is equal to x to the power n, then y is equal to 1 out of n plus 1. Like how we came about this thing is not what I'm understanding.
Okay. You know from your differentiation that y, let me give you from the generic formula, y is equal to x power n, right? You know that?
Yes,
Now,
yes,
when you differentiate, we shall say the y with respect to x will give us n, xn minus 1, right?
yes,
Now, when it comes to integration, we are asking ourselves, how can we move from here? Are you seeing? And
yes.
come back to the original thing that we had. And that is now the question that we are asking. And that's what the first thing was doing. Is that okay?
Oh, yes, teacher.
So that is what it was doing.
Thank you, sir.
Okay. Okay, I want you to summarize something. And now allow me to add something here. Now, what you have inside here, are you seeing this xn? Xn is your function. And now that function, let me say, what you are going to integrate inside here, we call it an integrand. So whenever you find an integrand, is what you are going to integrate to get the answer. Then dx is what you call differential. Then c is your constant of integration. Yeah. So summarize those key points and then we start. We are going to look at quite a number of examples. You'll be able to understand the concepts. When you finish to summarize, you let me know. Take an example for the last point, or even this point. Let me give you an example. Take an example. You may have something like this, 4x dx, and it's what you are integrating. This one means that you can remove this 4 and have 4 integral of x dx. That is the meaning. Then for this third one, for the third key point, it means that I can have my function 4x plus maybe 2x squared and everything dx. It means here you can separate and have 4x integrated separately, plus since you have a plus here, integral of 2x squared dx also integrated separately. That is the meaning of the key points. Uh, the formulas, no. For these formulas, you must now put them in the head. But the moment we start on some examples, they are going to start flowing. They are going to start flowing. So that one shouldn't worry. The moment we do one example, everything is going to start flowing. So when you finish, you let me know through the chat and then we continue. According to the chat, some people have finished. Yes, Melinda?
I had a question on the third key point. After I get your answer, when you integrate 4x dx plus the rest, for that first part, can you integrate it further?
Oh, no, now this one means integrate once.
Oh, okay.
And in integration, unless the question or the concept, those things of integrating more than once, you'll meet that concept when we reach integration by parts. That is integration 2. That's where you can meet such things where you're going to integrate twice and the rest. Okay. Yes, Emmanuel? Okay. Hope Martina, we are on the same page. So we can now start the integration. The first integration we do have is here. They're asking us that find y in terms of x for each of the following. This is the first one. Now, I want us to remember the concept of integration. Now, whenever you have anything you are integrating, what you are going to integrate inside here, this is your x power n with respect to x. This one means that you are only integrating those variables with x. So we have said that when we are integrating, I'm going to write my function here, which is x. I increase the power by 1. Then the answer, the new power I've obtained, I divide it. Then after you add c. So it's the same thing we are going to do here. In order for us to get y, this is the y here. To get it, we are going to integrate this function. So we have said we are going to have 15x. We are only interested in x because that's what we are integrating with respect to. So we shall add our 1 on the new power. The answer we have obtained, the new power, we divide it, which is 2 plus 1. Then after, we add a c. So that means here we shall end up with 15. 2 plus 1 is going to be x cubed out of 3, then plus the constant c. This is our y. But since this 3 and the 15 can go, so you can decide to reduce. So you shall have y is equal by 3, 1 by 3, 5. So it becomes 5 x power 3 plus a c. Now c is what we call the constant of integration. That c, it is the one that you are not sure whether the number that was there was 4, whether it was 3, or whether it was 2. So, but we shall look at it when we reach that point of obtaining a C. So that's how you do it. When it comes to part B, you do the same thing. But why don't you try out part B? Okay, let everyone first try out part B. Okay, yes, Enoch?
Part B, I'm having 7x power 7 plus c.
You have y is equal to 7. Oh, Enoch, you were mentioning something like 7, but I want you to look at it very well again. Yes, Enoch?
It's 2x power 7 plus c.
2x power 7 plus
Plus c.
c. Very good. Do we have that, everyone? Kindly let me know. Do we have that answer? Very good. The answers I'm seeing in the chat are very, very okay. Perfect. Okay. Okay. The answers are okay. So we are going to move on to the next. Okay. We have the next one here. Yes. The next one, still we do the same. What do they want? They want us to find f of x. Remember, in differentiation, your f prime can be written still as dy dx. Now, since this is f prime, we are going to find f of x. Now, when we are doing this, you do an individual part. You do individual. So, this is one. This is the second one. This is the third. So you integrate all the bits. So here we shall come and say this is f of x equaling 2. Now, since we are integrating, in case it had this coupling, the prime drops. So this will be 5x. Our power is 4, so we add a 1 on the power. Our new power now we have obtained is 4 plus 1. Minus, there is a minus here. I will set 2x. The power is 3. I add a 1. Divide by the new power formed, which is 3 plus 1. Plus, now this is where now you need to remember that this 2 here has an x here, but its power is 0. Please observe that in integration, that this x power 0 is the same as 1. So having 2 is the same as having 2x power 0. So we are going to come here and say this is 2x 0 plus 1 out of 0 plus 1. So here we shall end up with 5x. 4 plus 1 gives us a 5. Divide everything by 5 minus 2x power 4 out of 4 plus 2x. 0 plus 1 is a 1 out of 1. So when you simplify, this 5 and a 5 will reduce. So here we shall remain with x power 5 minus by 2 1 by 2 2. So we shall remain with x power 4 out of 2, then plus 2x. And this is our f of x. Class, hope that is okay. Yes, Martina.
So teacher, my question is, would you advise us to, let's say, work out 5x to power 4 individually and like the rest of the things individually, then like we add the answers, or you'd advise us to do it like at once?
Okay. It will depend on the number you are doing, but that approach, you can first, the only problem may come when you forget to carry the sign. That's where I may see the challenge. The challenge may come is, take an example, when you decide to carry, let me put here just my side work. When you decide to carry 5x power 4, and then you come and you carry 2x power 3, and then you carry the 2. And in the process, you forget when you are combining that this one had a negative here. That can be the problem with it. But it is also very good if you can do it as your side work, and then you continue. Okay. Yes, Ronald Matovu.
Teacher, you are forgetting to add a constant.
Oh, okay. Thank you. Thank you. So there is a C here that we have to add. Okay. Thank you, Matov. That is correct. Okay. So that's how you are supposed to do that part. Yes, Techno. Yes, Prince Sam.
Good afternoon, sir.
Good afternoon.
My question is, like, to reduce these fractions, can we divide all through or we multiply all through?
Oh, not really. Not really.
I have a
Okay.
Okay. Okay. Yes, lastly, Gilbert, I am taking an assumption that people are trying out this second number. That is my assumption. Yes, Gilbert?
Good afternoon, teacher.
Yes, good afternoon.
My answer for part B
Mm.
is x power 6 out of 2.
Okay, for part B, okay. It is?
F of x is equal to x power 6 out of 2. Then plus x cubed out of 3.
Okay.
Then minus x squared. then plus C.
Plus C. Perfect. Perfect. So hope everyone has that answer. So that is the answer. And you are going to notice that the more we do, you are going to find out that there are some steps you are going to be jumping. Eh? Yes. Okay, Shakira.
Having x first plus x to power x cubed out of 2 minus 2x to power 2.
You are saying?
I am having 2x to power 6 plus x cubed out of 2 minus 2x to power 2.
Okay.
Remember,
Shakira,
we had a
Shakira, explain.
master. Remember, it was 3x to power 5 plus
So
x to power 2 minus.
So can we add the 1?
Yes.
Then after divide by 5 plus 1. Did you have that?
Yes.
Then for the second one, what did you have?
I had x to power 2 plus a 1 out of 2 plus a 1
minus
2x 1 plus 1
out of
out of the 2.
Okay, out of the 2. So are you noticing that here is 3 out of 6, x power 6?
Yes.
Plus x power out of 3 minus
Yes.
2x squared out of 2.
Yeah, so
By 3, 1 by 3.
2.
So the 2 remains down, right?
Okay. Yes,
Okay.
I made a mistake.
Okay,
Thank you.
Okay. I
Yes.
think now let's continue. Now we have the other one. They want us to find y. Now, I want you to take note. Number 1, I've said you can only integrate in the video. And in between, we should always either have an addition or you have a subtraction. Whenever the sign is between the two things you want to differentiate or to integrate are not plus or minus, then you go on and first multiply. So here the first step we are going to do, we are going to first simplify. So you are going to first say, you open your brackets, you'll have your x squared plus the 5x. After opening the brackets, now that's when you can go on and integrate. Hope that is clear. Here you cannot just integrate the way they are. You can't. First simplify them and then go on and integrate. Okay. Hope that is okay. Newliat.
Excuse me, teacher.
Yes.
I have a question in the previous number. Why doesn't the f prime affect our answer?
It affects, now f prime is your dy dx. So it means that when you, like I've told you, like it was broken down into small pieces. So the answer we have got is the original one. So the moment you differentiate this final answer you have got, you'll go back to f prime.
Okay, Tia, thank you.
Okay. Okay. Swabra. Okay. Swabra, I'm failing to get you, and Emma. So here your answer. Yes.
Good evening. Good afternoon.
Good afternoon.
Teacher, I have a question, about this previous number. When about the answer we got, it was x plus x minus 2x, but the x had out of 2. Then teacher, Is it like when we get like what x power 2 out of 2, can we divide that 2 out of the power so that we can remain with the x, or we just leave it?
No, we had 2x power 2 out of 2.
Yes.
Yes, this 2 and this 2 can reduce.
What about when we have x power 2 out of 2? Do we
Now,
divide by the power, or we leave it?
we leave it. We leave it.
Okay, thank you.
Okay.
Evening, sir. Good evening.
Okay. So we are going to continue.
Excuse me.
So here our answer would be y is equal to x power 3 out of 3 plus 5x squared out of 2, then plus a constant. So that is what you do for that part. Then
Excuse me,
for the
sir, I have a
second
question.
part, yes, a question?
I was saying, if it is x power 3 out of 3, can it be a third x power 3 plus 2 wholes and a half x power 2? Or it has to be in that form?
I beg your pardon? You are saying whether it can be?
Can a third x power 3.
Uh-huh.
A third x power 3 plus 2 wholes, a half
Oh,
x
okay.
power
Now,
2.
you are bringing in, now, instead of bringing mixed fractions, better you leave them as this kind. Don't bring in those mixed fractions, but the answer is correct.
Okay, thank you.
So here, members, avoid writing in points, more so if your points are recurring, and avoid writing mixed fractions. Okay. Okay. Martina, can you take us through number 2?
Okay, Jay, I can try. So we can begin by simplifying like what we did for part A to get 6x to power 6x and the x power 3, 6x power 3 squared
Plus?
2x squared.
Okay.
Then after that, we're going to say y is equal to 6x 3 plus 1 out of 3 plus 1 plus 2x 2 plus 1 out of 2 plus 1. Then y is equal to 6x power 4 out of 4 plus 2x power 3 out of 3. And I don't know if we can simplify or we should just leave it like this.
Simplify, always. In case something can be simplified, you go on.
Yeah, so by 2 it will be 3, by 2 it will be 2, so it will be 3x out of 4, no, 3x to power 4 out of 2 plus 2x to power 3 out of 3 plus the constant of the integration, which is c.
Okay, thank you. That is correct. So let me hope that those are the answers we are getting. Now, still when we come to this last part, part D, you must first simplify it. You cannot deal with it the way it is there. Now, what do? I'm going to, this 2x power 3 affects every term we have up there. It affects every individual term. So I can write this first. I can write this first as x power 4 out of 2x cubed minus 2x out of 2x cubed plus 5 out of 2x cubed. and that is my original dy dx. Let me know through the chat whether members we are on the same page, whether that is okay. Is that okay to everyone? I'm separating now in the video terms. Daniela, you can put that constant throughout. You can put that constant throughout. It is very okay. Same page. Good. Now from here, this is where now you need to start remembering. So here it is okay to put your C throughout. It is very okay. As long as you have started integrating. Yes, Sobra.
About that, why do we divide by that 2x power 3 for all?
Because like,
because it's dividing all that number that is up. Is
yes.
it?
Yes, that is
Okay.
it. Okay. Now we come back here. Allow me to do this individually first such that people can be able to see it clearly. So the first one, you have x power 4 divided by 2x power 3. So you need to remember your indices. So here, there are 4 x's, there are 3 x's. So here we shall remain with 1 out of 2. Up we shall have 1x. Then the second one, we have 2x out of the 2x cubed. So these 2 and the 2 can cancel. Up you have 1x, down you have 3. So the down one will remain only 2. So you remain with 1 out of x squared. Then the next one, you have 5 out of 2x cubed. So this one, nothing will change. So I'm going now to come back here and I write this as 1 out of 2x minus. Here I'll remain with 1 out of x squared. Then the next one I'll remain with 5 out of 2x cubed. Hope that
Excuse
is
me,
very...
teacher.
Yes, please.
What, like, repeat for me, 1 out of 1, where is the 1 coming from? Because we had x power 4.
X power 4 is like Sobla.
Yes.
You have x power 4 divided by 2x cubed, right?
Yes.
X power 4 means multiply x 4 times, like this.
Yes.
Then 2x cubed means it is 2 times x 3 times.
Yes.
Now this x can cancel, this x can cancel, this x can cancel.
Oh.
That is how
So
it is cancelled.
1 out of that 2.
Yes, out of that 2. Okay. Now, still, when we reach here, I want us to observe something very important. Still, we are going to use our knowledge. We are going to use our knowledge of indices. From your indices that you covered, you remember very well that if I have x power negative n, this is the same as 1 out of x power n. Now, when you look at what we have here and what we have here, always your thing must be up. You can't integrate you can't integrate a fraction. So we must always convert our fractions into the power in this form. So can everyone first put for us, what is 1 out of x squared in form of a base and a power? Then, when we have 5 out of 2, here there is x cubed. What is it going to be in form of a base and a power? Can you first put your answer in the chat and we see whether we are there? Amal Immaculate has said x power negative 2. Good. Lugalama, that is very okay. Very good, very good. Those answers are correct. As I answer Navish. Navish, ask your question. Okay. Okay. I've seen your answers. Okay. So I'm going to go back. So this one will remain as 1 out of 2x. Then here, my answer is going to become... I'm not getting you.
Tabuli.
Uh,
Who's a mom? I don't know.
Oh, Sobra, your background. Navish, I've not gotten you.
So I was asking, I didn't get how you got to the one x out of 2 minus 1 out of x squared. I didn't get that part.
This step here, step number 3.
Yes.
This step, like this step we said, it came from here, that I have x power 4 out of 2x cubed. Now, you know from your indices,
yes, sir.
I can write this as 1 out of 2, x power. Indices, when you are dividing two numbers, you subtract the powers. So it can be 4 minus 3, which will give us 1 out of 2, x. 4 minus 3 is 1. Do you remember that?
Okay, thank you, sir.
That is the idea we are using. Okay, yes, Nach? Okay, now from here, we are going to go on and integrate. So I'll have my y. When I integrate this, I'll have 1 out of 2. Here it will be x power 2 out of 2 minus, I integrate. Now this is x power negative 2. So you integrate it, you say x negative 2 plus 1 divided by negative 2 plus 1. So negative 2 plus 1, I'll end up with x power negative 1 out of negative 1. Then the last one, I'll have 5 out of 2. It will be x power negative 3 plus 1 out of negative 3 plus 1. So when you continue, the denominators, they multiply. So you get x power 2 out of 4. This negative and the negative here, they are also going to reduce. This negative and the negative, they will give you a positive. So here you are going to remain with plus x power negative 1. Then here you have negative 3 plus 1. Negative 3 plus 1, which gives us negative 2 times the negative 2 times the 2 down. And we shall end up with plus 5 out of negative 4, x power negative 2. Now, your next task is to transform these powers which are negative into real things. So now I'm going to write this as x squared out of 4 plus 1 out of x minus 5 out of 4 x squared, then plus c. That is going to be my final answer. So that is how you attempt it. So, okay. Now, I'm not saying people are confusing. Prince, do not confuse the concept. When we have 5 out of 3, x down here, it is not the same thing like the other one you wanted. Those ones are two different concepts. There is a difference between x 3 out of 2 and 3 out of 2x. These ones are totally different. Pardon. Okay, I'm going to repeat from that last step. I'm going to repeat one more time for people who have not yet picked. I'm going to repeat. Allow me to first create space. Allow me to create space. And then I repeat. I repeat, I repeat. But in the process of repeating, I want people to try out to copy this first number. Okay, okay, no problem, don't write. Let me just put here. I want to first repeat for people who have not picked that thing. But in the process of repeating, those who have finished, those who have finished and have understood the concept, I want you to be working out this. All those that have understood the concept. Those who have understood the concept, be working on this as I explained. Now, friends, we have said we had reached this point. It was 1 out of 2 x minus x power negative 2 plus 5 out of 2 x power negative 3. Now, you integrate individual parts. So we say y is equal to, I start with the first one here. So it will be 1 out of 2 x, the power here is 1. So I will say 1 plus 1. Divide by the new power, which is 1 plus 1. I go to the next one here, which is negative. Then I'll have x power negative 2. I do the needful. 1 plus 1 divide by the new power, which is negative 2 plus 1. Then I continue to the next thing, which is 5 out of 2. Now I look at the power, which is x negative 3 plus 1 divided by the new power, which is negative 3 plus 1. Now from here, you continue applying. So here you can add your constant of integration. So I'll come back and say this is 1 out of 2. 1 plus 1 up is x power 2. Divide by 1 plus 1, which is a 2. Minus x. Negative 2 plus 1 is negative 1. Divide by negative 2 plus 1, which is negative 1. Plus 5 out of 2. The power is x. Negative 3 plus 1 gives us negative 2 out of negative 3 plus 1, which gives us negative 2 plus the c. Now from there, you are going to first reduce. You notice very well that this negative and this negative can be affected. So negative and negative, you are dividing, it becomes a positive. So I can first reduce and say 2. I want you also to look at these 2 downwards here. These 2 can multiply together. So I'll end up here with x squared out of 4, because 2 times 2 is 4. This negative and a negative will give us a positive, so it becomes negative 1. Plus the 2 and a negative 2 still will give us a negative 4, x power negative 2 plus the constant. Now, when you reach here, you are going to simplify. You remember from your indices, a power negative n is the same as saying 1 out of a power n. So in case I have x power negative 2, this is the same as having 1 out of x power 2. In case you have x power negative 1, this is the same as having 1 out of x power 1. So that's why here we shall come and say x squared out of 4 plus 1 out of x. Because anything power 1 is that same thing from here. So this is the same as 1 out of x. Then this 5 out of negative 4 is the same thing like writing negative 5 out of 4. But since this x is negative 2, I can bring it down and I write x squared down here. Then plus your constant of integration. So that is your y. And you end at that point. Hope that is okay. Let me take on one hand. Yes, Pavin.
Excuse me, sir.
Yes.
I've got an answer here. It says that x power 4 out of 4 plus x squared.
Okay, come again. X power 4 plus?
X power 4 out of 4 plus x squared. Then plus 1 out of negative x.
1 out of negative x?
Yes.
1 out of?
Negative x.
Like that, plus c?
Yes. Yeah.
Okay. I hope when you simplified here, this is what you are supposed to get. So you first show when you are simplifying each individual part, Then when you continue, this would be x power 3 plus 2x, then plus x power negative 2. So
Yes.
when you integrate, this becomes x power 4, that was correct. This becomes x squared, that was also correct. And
Then the
negative 2 plus 1. And this one, you'd have put it like this, eh?
okay, sir.
Better you put the negative here instead of down, but the answer is correct.
Thank you, sir.
Okay, thank you. Lugalama?
Yes, sir. For me, like um, at the end, I did this was like x power negative 1. Is it correct if you leave it like
At the
that?
end? No, at the end, better you take it back to the fraction, eh?
If you like, yeah. Okay.
Yes?
Thanks, sir.
Oh, okay, I didn't pick you. I didn't pick you. Well, yes. Okay, okay. Sorry, I didn't get your question very well. Okay, but let's now first continue and look at the other part. Now we have other items here. Now this time around, they have given us we have used the integral sign, and this is going to be the most common format you are going to be finding your things. Always you are going to find the integral sign. What does it mean? I have told you that whatever thing you're going to integrate, make sure you can integrate individual term. So you first go on and simplify. Don't go any step before simplifying. So I've told you this one, what we are going to integrate is what you call an integrand. So we are going to first simplify. It is very okay for you to have your side work when you are simplifying your work. No problem. So I know I don't want to go into this, but let me just go there. But there is no need because I know some of you already know how to expand this quickly. So now you expand, you say this is x squared plus 4x plus x plus 4, and this will give us x squared plus 5x plus 4. Members, I want to take an assumption that that step is very okay for everyone. Is that step fine to everyone? That step I have just finished? Okay, people are saying that is very okay. That is very, very okay. Okay, people have no problem with that. So I'm going to get that one. I put it back in my integral. So you have an integral of x squared plus 5x plus 4. And we are integrating everything here with respect to x. Now, here, like I showed you the rule, you can decide to integrate in the video. Someone can say, let me integrate in the video. In the video means you are going to separate and say, this is x squared with respect to x. Here there is a plus integral of 5x with respect to x plus integral of 4 with respect to x. It is very fine for you to integrate like that. Then you come here, you start integrating. This is x3 out of 3 plus this is going to be 5x squared out of 2 plus this is going to be 4x then plus a constant of integration. I've simplified a bit, but let me know whether it is fine. In case you are getting some challenges, let me know about it. Is the answer okay? Plus a constant always. Is the answer okay? Fine? Okay. Yes. Yeah. Okay. Can we now try out the second part? Can we try out the second part? I want you to first expand. First make an expansion of x minus 3 squared and get the answer. First expand that. Yes, Naki?
Master,
Yes.
I haven't understood here where you put the integration sign, like integrating the whole thing.
The 4,
Yes.
like we said, that 4 here has an hidden thing, and in
Yes.
4 has an x to power 0 that you don't see.
Yes. That one I
So,
understood. But I was saying, why do you like differentiate every term in its own way?
no, you can't. No, this step I've said, this step here, it is optional.
Okay.
This step here is optional. For
Yeah,
you may
that was the
decide to,
problem.
you may decide to do it at once.
Okay. Thank you, Master.
Okay. Enoch?
I like there is a question you had left us before you came to this. We were still repeating.
As if we finished that question. This question here?
Yes, like this one in the corner.
The answer is here. Did you have that answer?
Oh, yes, yes.
Yeah, the answer is correct. Okay, now we are on this one now. First expand, first expand. Yes, Navish?
Sir, on that part B, I'm getting the answers
First tell us,
as
what
x
did you
cubed
get when
out
you
of 3
expanded?
minus.
When you expanded, what did you get?
I got x squared minus 6x plus 9
X squared,
minus 6x plus 9.
Okay, good. So what did you get after integrating?
I got x cubed out of 3
Minus?
3x squared plus 9x plus c.
Plus c. That is correct. Is everyone having that answer? Thank you, Navish.
Yes.
Okay. Yes, Lugalama?
For me, when I expanded, I got x squared minus 9.
Okay. Lugalama, stay on and tell us how you expanded.
It was x minus 3 into brackets, multiplying x plus 3 into brackets.
Oh, now you are confusing two concepts, Lugalama. There is a difference between x minus 3 squared and x squared minus 3 squared. So for you, what you did was this. Yet the question wanted this.
Okay, sir. Thanks.
Okay. Okay. I think we are going to continue. Okay. We go to the next part. Unless someone is having a problem, that's where is 9 coming from? Samsung, I don't know whether you have seen the 9. The 9 came because of this expansion. Because I expect you to come and say x minus 3 into x minus 3. Then you expand. This is x squared minus 3x minus 3x plus 9. So this gives you x squared minus 6x plus 9. The person of Samsung, let me hope that is very, very okay. Okay, so we are going to the last one. Still that last one, I want you to first go. Okay, to go on and first expand. Don't assume now like most when they are roots. Go on and first and first expand. So allow me for that one to create a new screen that is a bit bigger, such that we can walk the journey together. So allow me to create a screen here. Okay, this is my screen that I've created. So I want to write that number again. So what do we have? So the question gave us integral of, this was 2 root of x minus 1 squared with respect to x. Now it means you are integrating with respect to x. Now I want you to first always expand it. They told us squared, and we know squared means multiply it twice. I'll have this minus this into 2 root of x minus 1. And now we know that when we are multiplying, the whole of this will affect this. So you open very well that 2 root of x into 2 root of x minus 1. Then have this multiply with this, which is minus 1 into 2 root of x minus 1. Now here, you are going to bring in your knowledge of surds. So here we shall have 2 root of x times 2 root of x minus 2 root of x minus 2 root of x plus 1. Because negative 1 times negative 1 is 1. Then here when you open, you have 2 times 2, which is 4, into root of x squared. That is the meaning. Minus 2 root x minus 2 root x, which gives us 4 root of x plus 1. Now, root of x squared is the same as x. So this gives us 4x minus 4 root of x plus a 1. Kindly, did we have the same answer? You can let me know through the chat and let me know whether we are on the same page. People are on the same page. Very good. So that is what we are going to integrate. So I'm going to come back here and I will say that the integral of 4x minus 4 root of x plus 1 is what I'm going to integrate with respect to x. Now, what is very important is this one, root of x. Now, you have to write that root of x in form of power as well. So that is 4x minus 4x power a half, then plus 1. Hope members remember that. So this is the same as having an integral of 4x minus 4x power a half, then plus 1. Everything integrate with respect to x. So when you reach here, you do your math, 4x squared out of 2 minus 4x power half. Here, let me add, because I know you may blunder if you don't show. Then plus x plus the constant. So allow me to first deal with this one. Now here you add very well that a half plus 1, which will give us, this is 3 out of 2. Then that means you have this up and down. So here, when you reduce, you have 2x squared minus 4x power 3 out of 2, everything out of 3 out of 2. Now here, feel free to do your side work such that you are very sure of what you are writing. So when you are doing your side work here, be very sure that I'm going to deal with this very well. So it is 4x power 3 out of 2 divided by 3 out of 2, which is the same as 4x power 3 out of 2 times 2 out of 3. I don't know that that is now very okay. So that means you are going to have 4 times 2, which will give us 8 out of the 3, x power 3 out of 2. So that is what I wanted to bring to your attention, plus the c. So you'll end up with 2x squared minus 8 out of 3, x power 3 out of 2, plus x plus c. Now, you can go on and make this answer much better. More so, looking at where you have x power 3 out of 2. Now, since our function was in roots, you can make this answer to be in roots by writing it as root of x cubed. So if you want, you can go on and say this is 2x squared minus 8 out of 3, everything into x cubed plus x plus c. Yeah, so that is your final answer. Kindly let me know whether you have picked the concept or whether we are lost. Yes, let me start with Muha Semin.
Hello, sir.
Yes.
Yeah, I got lost from here when we are expanding. The four two root of x times 2 root of x. That's 4 root of x squared. Then this minus 2 root of x minus 2 root of x plus 4. I thought we are getting plus 4 root of x, not minus 4 root of x. Yes, quite.
Tell me,
because these are two negatives. 2 root of x minus 2 root of x. When you're multiplying them,
okay, I beg your pardon. Which part is confusing you?
this step here, 2 root of x times 2 root of x. And then minus 2 root of x minus 2 root of x plus 1. Then here you get 4 root of x squared, but this one minus 4 root of x. Are we not supposed to multiply?
Oh, here we are adding. It's like having negative 2 minus 2.
Oh,
Negative
yeah.
2 minus 2, you end up with negative 4.
Yeah, I'm getting.
Okay. Fred? Fred?
Sir,
Yes.
I'm having a question. Just doing few minutes later, but I'm okay with everything. But the only problem I have, why are we adding a C there?
Oh, now C, I explained that C is the constant of integration, that you are not sure which exact value was on that function for it to be differentiated to get what we had at initially. So if you remember, the first thing I showed you the box, here, the box I showed you that this 5x power 4 could have been differentiated from any of these 6 functions and more. That the number of functions that you can differentiate to get that function are infinite. They are very, very many. So you cannot be sure whether it was 4, whether it was 7, whether it was 0.5. So that's why you put that C to show us that there are quite a number of constants which when you add, you get the exact value. Fine? Hope, Fred, that is okay.
It's okay.
Okay. Then lastly, Daniel and Enoch. But as Daniel and Enoch are coming on, allow me to put for you here, to project for you something. Yes, Enoch?
So, sir, like I'm having a different answer.
Yes?
I don't know if it has. I'm having a different answer. I don't know if it is having anything wrong or what. Like instead of having the 8, wherefore, like instead of having the 8 over 3, my answer is y equal to 2x squared minus 4 root of x cubed over 1.5 then plus x plus c. I've included the 1.5.
I'm not getting you.
Like my answer is having a 1.5 somewhere on this very number I've been.
1.5?
Yes, it's having a
1.5 was the power.
was a power.
Yes.
Like I've used,
I
there
think
is a
you
law of
mixed up the
indices.
power.
No, like there is a law of indices I've used, like to bring back the root and then power the 3 to x.
Okay, let me be putting for people here, right? And you tell me the steps. You tell me that step that gave you that law.
Okay.
Which law was that?
Like there is this law, let me say
People,
you're
you are
having
trying for me part D. Members, we are trying part D. It was?
If I'm having x power 3 over 2.
X,
and then
when you have?
X power 3 over 2.
Uh-huh.
No, like when the 2 is also power.
Like x power 3, everything power 2.
No, like when the power is 3 over 2.
Okay, x, like this.
Yes. And the whole thing to root of x.
It transforms into?
Root of x power 3.
Yes, that is correct.
Yes, just that. I'm asking what if I put like the point there? Because if that was the power, we had to divide again by that very answer, which is 3 over 2. Then for
What
me,
if you
just
do? X power 1.5.
No. Remember, that was also part of what we were supposed to integrate.
Yes.
Then we have to put it out of the current power that has been gotten.
Oh, because the current, no, okay, let me first take you back. What we had,
yes,
what we had to integrate initially was a half.
Yes.
It was not
Yes.
3 out of 2.
Yes.
Yes.
So at that point, that's is it the third last step? I'm asking, what if I turn that 3 over 2 that is down, I turn it to 1.5, then I give that as my answer.
Oh, then you give 4 out of 1.5.
Yes, please.
Here you have not simplified.
Oh.
It is not simplified. So you have to go on and simplify.
Okay, thank you, sir.
Okay. Everyone, we are trying. I want you to try. We are trying part D. So I want you to try for me part D. After, you can drop your answer in the chat. Try part D and drop your answer in the chat. Okay, as I pick one more hand. Yes, Fred? Pavin and Fred?
Good afternoon, Master.
Good afternoon.
Have got negative 3 out of x plus c.
Oh, for this one, you have got your answers, negative 3
out
of
x
x
plus c.
Okay. Can you
Yes.
first take me through? Okay. Okay. How did you first write your function at first?
I first brought the x up.
And it was 3?
3x power negative 2.
Okay, good.
Then I added the 1. I got a new power as negative 1.
Okay.
Then I divided by that new power. Then I placed the x down.
Okay.
Then the numerator became a negative.
Okay. Okay.
Yeah.
Perfect. Perfect. That is okay.
Okay, sir.
Okay. Okay. Now, those who have finished, I want us to try part E as well. After drop your answer. I'm seeing the answers in the chat are okay. Except for Ed Boy. Do not forget the C always. I don't know whether Bridget. Oh. Whether Bridget, you notice. You can use, instead of sides, feel free to use indices. You get the same answers. You get the same answers. So we are doing now the second part. We are doing part E. Lugarama, Maria K, Imran.
Yes.
Excuse me, teacher.
Yes.
I was just inquiring on that part, like on that step where the previous person who just gave an answer was like 3x then to the power -2. Let's start from there. I thought you were like we are supposed to add 1 to the power, then divide by the new power, right?
Very good.
Yeah. So me on that step, after doing that, I was left with 3x to the power. After like adding 1 to -2, I remained with -1, right? Yeah. Then I've actually seen my mistake.
Okay.
Yeah. Thanks.
Okay.
Good afternoon, sir.
Good afternoon.
On that part of E, my answer I've gotten it as y is equal to -1 out of x squared.
Here,
Yeah.
-1 out of
x squared plus c.
x squared plus c. Like that?
Yes.
Okay. Okay, that is okay. Okay. Hope the rest are also getting the same. So I expect you do not carry the 2. So I expect you to have carried this, something like that. Then from there, you say this is 1 out of 2, x power -3 plus 1 out of -3 plus 1. Now, I'm coming back on this answer here. The person who has given us, I want you to check out. Something is not adding up. Remember, always, when you are to write it, this becomes 1 out of 2, x power -3. So you cannot carry the 2 unless if you are carrying the 2, it becomes 2 to power -1, x power -3. So from there, you are going to come and say this is 1 out of 2, x power -3 plus 1 out of -3 plus 1. So which will give us 1 out of 2. This gives us -3 plus 1, which is -2, out of -3 plus 1, which gives us -2. So 2 times -2 is -4. So you remain with 1 out of -4, x power -2, which you can now write as 1 out of -4, x squared. And to write it much better, you can write it as -1 out of x power 2. So that is what I expect you to have. Yeah. Okay, can you do the last part, part F? Plus C. Plus C. Don't forget that plus C. Okay. Okay. Oh, we are doing part F now. We are doing part F. Okay. Yes, Victoria. Victoria.
Sir, for part F, I'm getting 8 root x plus c.
You are getting?
8 root x square root of x plus c.
Like that?
Yes.
Okay. Let me hope this is how you have approached it. Have you done that?
Yes.
Then from there, you went on and said 4x power negative a half, right?
Yes.
Then from here, I expect to say 4x negative a half plus 1 out of negative a half plus 1, right?
Yes.
Which gave you 4x power a half out of a half. So this a half will give us 8x power half, which is the same as 8 root of x plus c. Okay. So I want us to, we are going to end here. Allow me that we end here because I have a meeting starting at 4. In fact, it has already started. So I want us to end here. But now I want us to take a screenshot. Take a screenshot. You are going to try all the numbers. You're going to try all the numbers. Yes, but here where you have a root, do not forget your knowledge. Do not forget your knowledge of indices. So I expect to write here 5x squared out of x power half. Then use your indices here to say x 2 minus a half, and then you continue. So I'm going to take an assumption that you have taken a screenshot. That is my assumption that you have taken a screenshot. I'm still adding you more numbers. Take a screenshot of those ones as well. Okay, kindly let me through the chat whether we have finished to take the screenshot of all those numbers. Okay. Yeah. Okay, so we shall start from there. I had prepared a lot. I thought that we could be able to complete, but let's first work on these ones. Then we can agree on Thursday. I know you noticed that there is some research work I had put. Unfortunately, I have a class on Thursday during that time from 2 to 4. But if you have energy, we can meet again for math at 4, from 4 to around 6, or from 4 to around there. So you can let me know in case it can work for you. We can do it that way. On Thursday, instead, we have our research work from around that time. And then just put in the chat that we agree. If you agree, we can do it that way, such that we meet from from 4 after, I think, senior 3, there's a class I have there. And then we continue with integration. Okay, so those who have agreed, let's meet on Thursday at 4, from 4 to around 5 something, and then we continue with integration. Otherwise, thank you so much for attending. Complete the numbers. I will be sending the answers you are supposed to get. I think after 1.5 hours from now, after everyone has tried out. Thank you and have a lovely afternoon. Bye. See you.